Okay, welcome everyone. On behalf of Women Who Code, I want to welcome you to Coursera today. Coursera has been really helpful in hosting this meetup. So we're really grateful for them that they wanted to host this meetup for us today. So can we get a round of applause for Coursera for organizing this meetup today? So with that said, we're on a tight schedule, so I'm going to hand it over to Emily, who has been organizing the meetup, basically. Please welcome Emily.
Hi, my name is Emily Sands. I'm a data science manager here at Coursera. And again, on behalf of Women Who Code and also Coursera, welcome to this evening's event. Why are we here on this rainy Wednesday? First of all, I'm super impressed you guys made it out. I think we're here for sharing and learning and community. We're here to support each other in continual growth, technically and professionally. We have an incredible group here tonight. I've talked to many of you who are currently data scientists, others who are looking to transition into the field. We even have a smattering of very warm supporters from a range of other disciplines who just wanted to be here this evening to learn more about what we're working on and to support us in the journey. So, this is a great way to kick off 2017. I'm grateful to each of you for coming out. A quick word on the agenda to situate us this evening. So hopefully you've all had a chance to grab some food and drink, to mingle, meet some people in the room. We're about to start 5 lightning talks. I'll get us started and then hand it off to 4 of my awesome colleagues. After the talk, all the speakers will be back up here for Q&A. So please think about your questions, save your questions, and then we'll close the evening with some additional time to mingle and meet the other fantastic people in the room tonight. So to get us started, let me briefly share my perspective on data science roles and paths. And the motivation here is really a question that I get quite frequently about what is data science? What skills do I need? What will I do? Who will I work with? What will my journey look like? And this is, of course, a question that I get from people who are looking to transition in the field, people who are in academia today, or people who are in other roles in industry. But what strikes me is that I frequently also get this question from people who are currently data scientists today. And I think that speaks to how broad and expansive we know this field is. So tonight I'm going to lay out a framework for thinking about data science roles, potential paths in the field, and to start, sort of, what is data science? So I thought about just putting up, Harvard Business Review's statement that is the sexiest job of the century. I decided to go with something more concrete. So here's one popular answer. A data scientist is a person who is better at statistics than any software engineer and better at software engineering than any statistician, right? So this definition, yeah, right. This definition is broad, but it's pretty focused on the skill sets. Here's another. This one's from Michael Hochster, who leads research at Pandora. And Hochster says that data scientists are people who work with some mix of coding and statistical skills. So again, emphasizing the skill sets, who work on making data useful in various ways. And I like this because, we can concretize it. We can think about how do data scientists make data useful? And in particular, what do we do that's valuable? So at tech companies, including Coursera, there are 2 main ways we make data useful. The first is through decision science, and the second is by building data products. Let's dig in on each. So in decision science, we're really focused on developing and testing hypotheses that are key to product and business direction. Here at Coursera, this work informs how we grow our platform, how we monetize our users, how we improve the learning experience, and really so much more. And the technical piece can often be accomplished with, statistical modeling on existing data. In cases where the existing data is not sufficient, we often run and analyze experiments. And of course, it's not just about these methods. It's about the product and business intuition and the analytical creativity that informs what questions we ask and how we go about finding solutions. So what about data products? So in the case of data products, we're more focused on building products that, in the words of DJ Patil, who's the White House chief data scientist, probably the coolest title a human could have, and an early data products leader at LinkedIn, quote, facilitate an end goal through the use of data. So Like decision science, building data products demands a keen eye for what problems we're solving, how we're solving them. But relative to decision science, this work generally leans more heavily on the engineering and machine learning tool set. So quick poll, can we get a show of hands for people who would not self-identify as data scientists today? Okay, so that's like a pretty strong contingent. So for those of you who are newer to the field and maybe thinking, how do I fit in? How should I position myself? Here are a few questions to get you thinking. What do you love? Are you more into stats or ML? Do you particularly enjoy experimentation or coding? At night, do you dream about analyzing data to find out interesting things, or do you dream about actually building data products? And who do you like working with or thinking like? Is it product managers or back-end engineers? So I'm going to give everybody just 15 seconds to put themselves in the different cells. So if you find, those fastest 15 seconds, if you find yourself drawn to the first column, decision science may be more your flavor. And if you see yourself more in the second column, data products may be a better fit. But as with most kind of Cosmo-style quizzes, most of us don't fit cleanly in one bucket or another. And what I would say is that that's perfectly okay. In fact, I'd encourage all of us to think about our data science careers as a journey that very likely involves component parts of both of these types of workflows, and to allow ourselves to move along that journey depending on how our interests evolve and depending on how the relevant opportunities come in front of us. So another quick poll, raise your hand now. If you raise your hand for this one too, I'm going to know if you're currently working in the decision science space. So I'm thinking, people who use statistical modeling, experimentation to inform product and business direction. Okay, raise them high, high, high. Okay, good. Keep your hands up if you're interested in exploring data products. Okay, literally no one put their hands down. That's amazing. So for those of you who may now or down the line want to leverage your strength in decision science to get more exposure to data products, I'm going to give 3 sorts of hybrid projects that might help you in that path. And these are actually the sorts of hybrid projects that decision scientists at Coursera have taken on in order to get more exposure to data products. The first is to become an experimentation partner on one or more data products, right? So your company today probably has data products live in production, and the teams are testing and iterating on those products. You are an expert in experimentation, design, and analysis, so get in there, work on those products. And this is a great way to actually get more exposure to the nitty-gritty of how they work. The second is that you can suggest and implement changes to data products that maybe aren't getting the love they deserve, right? So even here at Coursera, we're not that late stage as a company, but I can think of a couple data products that are relatively unloved. And as a decision scientist, you can take your ninja analysis skills, understand what about that product is working and not working for whom, identify testable hypotheses about how to improve it, and if you're really feeling ambitious, maybe even pair code with someone who's worked on the product before to test out the changes. And third, with the exposure you have to the product and the user experience in your current role, you might also be able to identify new areas where data products could be powerful. You could even prototype early versions, and if you're thinking, but I'm not an ML engineer, how would I do this? I think one thing to remember is that many data products, including data products here at Coursera, start out as relatively basic algorithms or with simple rules-based algorithms or powered by basic logistic regression. So I think the opportunity is there, and you can use your current strengths to grow in this new area. What about if you want to move the other way? So of course, there are also hybrid projects that can provide relative growth opportunities in applied statistics and experimentation for those who are currently working on data products, either as a data scientist or as an engineer. First is identifying potential front-end improvements for the data product, right? So you know a lot about how the algorithm works, how it should be served to learners. You can dig in on the data and understand whether there are front-end changes that might facilitate the user's consumption of that product. So for example, if you're working on the search ranking algorithm, don't get too deep in exactly how the algorithm works if you're interested also in exploring what the user experience might look like, right? So for example, do you need autocomplete or spell check or related searches functionality? And do you see that need in the data? Second, you can work with the relevant PM to design and implement tests for some of your ideas, right? So as the expert, you can actually build out the relevant models needed to test it, but this will also get you direct exposure to the feature iteration process. And finally, you can identify new applications for your work. So you can find places in the product where your model might be useful and pitch those products based on what you're seeing in the data. So to sum up, 3 brief tips on how to think about your role and path within data science. The first is start with what you're uniquely good at. Your current strengths can and should inform how you position yourself in the field and how you establish yourself in new roles. The second is figure out ways to leverage your strengths to learn and grow in other areas. So this might include using your strengths in stats and experimental design to learn more about data products, or conversely, using your experience in data products to get more exposure to applied statistics and experimentation. And third, and I would argue probably most importantly, check in regularly with yourself about whether you love what you're doing, right? As we've discussed today, data science is a big and broad field. It means a lot of different things at a lot of different places, and it spans industries. So if you're not doing something today that really feeds your soul and speaks to your strength, figure out how you can. Don't be afraid to push yourself to a different role or a different company or even a different industry. So the rest of tonight, my teammates are going to be talking about a selection of decision science and data products work in their day-to-day here at Coursera. And we hope that the methods and tools and approaches will be generally extensible to your own workflows, but the examples themselves will be Coursera specific. So let me briefly highlight why I think Coursera is interesting as a case study in data science. 3 reasons. The first is hard problems, right? So there's a clear need here to make data useful. Providing universal access to the world's best education is our mission. We believe it's an important problem, but we also believe that there's not going to be a single clear solution. So if you consider just the Discovery Challenge alone, right, we have 23 million registered learners. These learners are from every country in the world. They come in with a diverse range of backgrounds and interests. And we have over 1,800 courses for these learners, right? From universities, again, around the world in a range of subjects and difficulty levels. How do we match the learners with the right content to meet their needs? Once they're matched, how do we help them get through? How do we ensure that they're having a good learning pedagogical experience? All of those are questions that I believe we have an incredible opportunity to answer with our data. And in particular, I think we have 3 types of data that are valuable for answering these questions. The first is observational, the second is experimental, and the third is reported. So as we think about our observational data, here we're talking about our 100 million enrollments on the Coursera platform, from which we learn who is taking what courses, how are they progressing through, where are they getting stuck, how are they getting unstuck, right? But even with that wealth of observational data, there are cases where the observational data alone is not enough, right? And in those cases, we can lean on platform experimentation to test our working hypotheses and figure out how to evolve our features better and faster. And third, where both observational and experimental data is lacking, we can actually ask users directly. So our users have been incredibly supportive over the history of Coursera in providing us guidance on what's working and not working for them and how we can make it better. We'll talk about all 3 types of data tonight, and I suspect all 3 types may have applications in your field as well. And finally, many of the challenges we face are actually directly solvable with data products. So if you think about a user comes in and searches for a course, how do we rank their results? Or a user enrolls in one course, how do we serve them personalized course recommendations for what they should take next? Or a learner is interested in a course but wants to know if he or she is ready. Or a learner is progressing through a course but maybe is at risk of getting stuck and we want to serve them targeted interventions, right? All of these are data products that we believe are key in actually unlocking universal access to outstanding education. So with that, let's actually dive into some concrete examples from the team. Up next, Catherine is going to highlight some of the ways we use A/B testing to build better products. From there, Ning will introduce how we can leverage a particular type of data, the learner voice data, to power both our decision science and our data products work. Aarong will cover a couple examples of data products, in particular in the top of funnel or discovery space. And Wen will close out the talk with her perspectives on the transition from academia to data science and on preparing and transitioning yourself in the field. So with that, let me hand it off to Catherine Wong.
Short people mic. All right, thank you, Emily. Hi, everyone. I'm Catherine, a data scientist at Coursera, and I'm here to talk to you about A/B testing our way to better products. On the path to developing better products, there are numerous forks in the road where we may be called upon to make a choice between one path and the other. Robert Frost summarized the considerations of making such a choice in his poem, The Road Not Taken, where the narrator famously chooses the road less traveled by. When I was taught about this poem in school, it was framed as a battle cry for the ideals of individuality and perseverance in innovation. However, I recently stumbled upon another interpretation of this poem. In the poem, the narrator comes upon a fork in the road, and for almost every visible feature, they actually cannot see any difference between the two roads. Both roads pass through the same wood, both are covered in leaves, and both look about equally worn by previous traffic. Being one person, the narrator cannot travel down both paths simultaneously, so they choose based on one small arbitrary point. They choose the path that has slightly more grass, which they take as an indicator that the road has been less traveled. In doing so, the narrator actually feels some regret because they feel this choice has made all the difference. They will likely never know what lay on the other path, and more importantly, what good things they may have missed by making the choice that they did. Now, putting on my data scientist hat, when I read this interpretation, it struck me. The traveler's downfall is a lack of data. If only the narrator could have collected data on both paths, they could have made an informed decision and spared themselves a lifetime of regret and uncertainty. And that's why A/B testing is one of the most powerful tools in the decision scientist repertoire. It's a tool that allows us to rapidly bring resolution to otherwise complicated questions and ambiguous decisions. So in the business case, when making decisions on product direction, one of the biggest advantages that we have is that we're not alone in the woods. A designer may point out the path with the most delightful aesthetic. An engineer may propose the path that leads the traveler to their destination fastest, and a product manager may call for the path where the trees have the best potential for growth. While these additional insights are beneficial, they can quickly make a decision start to look like this. That's where A/B testing comes in. By testing our hypotheses, we can validate ideas and align on the new ideas to pursue. In particular, because companies have so many users, rather than placing a single traveler onto a single path, we're able to place a multitude of users onto each potential path. Then we can measure the impact of those paths by collecting data about what users actually do once they're there. But it doesn't end after we've made just one decision. Once we've chosen the validated ideas and measured their impact, we have a new baseline for our product's performance. In the process of getting there, we've likely generated additional hypotheses by observing user behavior in the test. We can test additional hypotheses against the new baseline again and again. Ideally, through this process of continuous hypothesis-driven improvement, we have a structured, reproducible method for exposing our users to better and better experiences. So let's get started with a toy example. Here at Coursera, we believe that happy, excited employees are key to achieving our ambitious goal of transforming lives by providing access to the world's best learning experience. Let's say that we believe that t-shirts are an important input to employee happiness, and we have two possible color options, purple and red. We'd like to design an A/B test that will help us decide which color shirts to provide to our employees. We randomly assign a representative sample of employees into either Group A or Group B, providing Group A with the purple shirts and Group B with the red shirts. Next, we will measure their excitement through photo proof, which we believe to be a leading indicator of long-term employee happiness. Looking at this photo of Group A, they do look pretty excited. Everyone's smiling, we see a couple of props, and there's even a peace symbol thrown there. What about Group B? Wow, Group B looks even more excited. They have their hands in the air, tons of props, and even a bunch of silly faces thrown in. Based on this completely objective and statistically sound method, we determined that Group B is more excited than Group A. Now, because we assigned users to each group randomly, in theory, any changes that we see in Group B relative to Group A are caused by the difference in their experiences. Assuming that we were extremely careful when implementing the test to change only one thing for each group, their shirt color, we can actually say that the red shirts caused the increased excitement. Since we believe excitement is a leading indicator of long-term employee happiness, we can roll out the red shirts to all employees, expecting that we are taking a positive step toward our goal of happy employees. All right, let's take a look at a more real-world example using a test that we performed here on Coursera's website. When a user first arrives to our site, we help them onboard by showing them a short survey and using their responses to suggest courses and course sequences that may best support them in meeting their goals. Currently, we take users to the recommendations page as soon as they finish this survey. The goal of this service is to give users a starting point for using Coursera courses to continue their education. However, no matter how good our recommendations are, if users don't click on them, they may drop off at that point and miss an opportunity to continue learning. Thus, we want to improve clicks on recommendations, which we treat as a leading indicator for longer-term engagement with courses on our platform. One of our team members comes to us with an idea. Hey, what if we show users a loading page in between the onboarding survey and the recommendations screen? Other companies that provide recommendations, such as Kayak or Hipmunk, have cited successful responses from adding a loading page between queries and results. Behavioral economics suggests that this may be due to a perception of effort. Users value seeing that thought and effort went into providing the recommendations that they receive. They may think that the recommendations are of higher quality or value because they took longer to generate, and in turn, be more willing to spend their time exploring them. On the flip side, companies like Amazon and Google have done tests around page latency, where they showed that even a small 100 millisecond delay could cause dramatic decreases in overall user engagement. With that in mind, we'd like to design a test to determine whether we should add the loading page or not. Before we even start implementing the test, we should align on a few key pieces of information. This will help us to ensure that the test answers the questions we're interested in and is targeted towards the goal of interest. For this test, our goal is to increase users' long-term engagement with courses on our platform. The hypothesis here is that if we have a loading page, that will help us to meet our goal by increasing clicks on recommendations results. Now, in this particular case, I chose our metric of interest to be clicks on recommendations results. However, if we were testing a different feature or had a different goal in mind, we might choose a different set of metrics to monitor. Now, to test this, our design is going to be an A/B test. We'll randomly assign half the users to Group A and the other half to Group B. We won't show Group A a loading page, and we will show Group B a loading page. We decided that we would be able to use an A/B test in this case because, one, we do not anticipate any ethical or perceived fairness issues with giving users these two different experiences. A loading page generally has a pretty small impact on a user's everyday life. There are minimal network effects between variants. It's unlikely that the two experiences are going to spill over and affect one another. And we did our due diligence and checked with all the other tests that we were running on our site at the same time and saw that it's not going to interact with those either. Lastly, it's a relatively lightweight effort for our designers and engineers. This means even if the test does not succeed, we have not spent too many resources on setting up the variants. If this was a larger design or engineering effort, we might consider testing a smaller subset of changes to get an early indication of whether to perform the larger test or not. Luckily, this change happens to be already a reasonable size. Finally, we want to look at our success criteria. In most cases, we want to ensure that our metric of interest improves significantly and is worth the cost of implementation. For example, if there's any upkeep that has to be done once the new feature is added, we may want to see a slightly higher improvement to metrics to make the maintenance worth it. We set success criteria in advance to ensure that they're not influenced by either hindsight or confirmation biases. And as one more benefit that I won't go into too much detail about tonight, there's also calculators out there that can help you determine sample sizes needed to achieve statistical significance in your tests. If you set your success criteria in advance, then you'd be able to tell whether you have enough users or time to actually do this test. All right, now we have alignment on our test setup, and we can implement and run the test. There are a number of services out there that can be used to perform the randomization and serving of the correct variant to users, including Optimizely and Google Analytics. These services often help you to track your metrics of interest and compare the results between variants. Here at Coursera, we actually use a service called Epic that was built in-house by our data infrastructure team. Epic randomly assigns our users to Group A or Group B. Then it applies significance tests to the metrics of interest to give us confidence about whether the changes that we are seeing are unlikely to be due to random chance. After running the test using Epic and collecting data on users from the two groups, we have our results. Wow, it turns out that users who saw the loading page demonstrated increased clicks on recommendations results. Now we have confidence that the changes that we introduce will help us meet our goal of increasing long-term engagement with courses by increasing clicks on recommendations results. Now let's try to go one step deeper to understand what's causing this improvement. First of all, the most obvious change is the new loading page itself, which adds a waiting period before the user sees their recommendations results. Next, we can look at the content of the page. There's also personalized copy letting the user know that these recommendations are specific to them. Then there's also an animated reminder of which recommendations are being generated. It's the interaction of all these changes that has led to the change in the metrics that we observe. If we removed or added any changes, the results of this test would not necessarily carry over to the change experience. For instance, if we decided, oh, what if we add a video, or let's remove the text from the loading page, we would need to do another test to understand the full impact of that new change. Okay, now the test is complete, we've measured the impact, and we've rolled out the winning variant. We're almost done. As we're considering what we've learned from the onboarding test, a new hypothesis comes to mind. Hey, what if we put a loading page between the search query and the search results? And so the cycle continues. All right, now to summarize, here are my top 3 tips for A/B testing your way to better projects. Tip number 1, leverage A/B testing to inform direction and strategy. Don't just wonder what might have been, test it. Tip number 2, align on the problem you're trying to solve before running the test. Make sure that the test you plan to implement will actually bring you closer to your goal. And tip number 3, dig into mechanisms to better understand the bounds of what the test measures. Doing so can bring clarity to what the test results are really teaching you. And with that, I'd like to introduce our next speaker. Now, in the onboarding example, we saw that users did increase clicks on recommendations after seeing the loading page. But recall that the behavioral economics theory is that this is because the users perceive the results as higher quality or more valuable. However, without asking users, we can only say what the users did. We don't actually have any information on what they were thinking. Next up, Ning will talk to us about how we can hear our users' voices through data. Yay!
Okay, so thanks, Catherine. Okay, hi everyone, my name is Ning. I'm the data scientist on learning experience team at Coursera. So I will talk about user voices at Coursera. So as you just heard from Catherine, we use user behavior data in A/B tests to help us make informed decisions. But there are questions that cannot be answered from user behavior data. Questions hard to get a clean read from user behavior data. Questions even like who our users are, what do they like, etc. So for those questions, why not just ask our user directly? So in this talk, I'll first go over some examples of how we do user voices at Coursera, and then I'll move on to some general learnings. Hopefully could be informative in your own work. Okay, so let's jump to some examples here. So the first example is really straightforward, is user profile. We just ask our users who they are, what they like, what they want, and then we use that data to power personalized recommendations and onboarding experiences. The second example is course rating. We ask our learners, do they like the course? Are they satisfied with the course? And we use this data in a lot of different places. First of all, we display that data directly on the course landing page so that other browsers can see what people have been saying about this course. Hopefully, this can help them surface some good quality courses. We also treat this as a top-line company metrics because we care about course quality immensely at Coursera. We want to treat this as something we want to keep optimizing for and improving on. And of course, we use the detailed feedback for each individual course improvement. So the third example is self-assessment. It's still a feature in active development. We'll ask our learners, how do they feel they understand the concept from 1 to 10. There are many use cases for this. The first one is purely pedagogy benefits. A lot of theories have pointed out that by checking in with learners frequently and regularly, forcing them to reflect back on their learning gains, it will improve the learning outcome greatly. The second use case, this is our first step towards personalized learning. Say if you say, oh, I don't quite understand the concept, we will probably lead you to some supporting materials or a practice quiz to help you digest knowledge a little better. Or if you say, I'm a 10, I understand this concept perfectly, I can teach others, we'll probably skip the review sessions for you so that you can complete the course in a shorter time frame. So, and so much more. We also do tons of user research, interviews, targeted surveys. We also have a crowdsourcing tool in place. So we've been doing this for a while at Coursera, and here are some learnings from our own experience I want to share with you today. So the first one is entry point. It can be tricky. Entry point means where you place a survey or where you ask a question. It can create some hidden selection bias. This is particularly common in Coursera's use case, where the typical learning experience will last 4 to 6 weeks. It's not a one impression or experience at all. So in the example of when should we ask our learners if they are satisfied with the course? Should we ask that in the beginning or the end of the course? So the chart on the right you see is a course continuation chart. It tells you at each point how many learners are left compared to the beginning. So say we can ask a question in the beginning where we get more people responding, but it's doubtful if they have enough exposure to the course content yet. Or alternatively, we can ask a question at the end of the course. They'll definitely have a full course experience, but you can see all the people left by that point are pretty much self-selected themselves, meaning only the people who like the course, think the course is important, or in some other ways really inner motivated people are much more likely to complete the course. So if we are just asking those people, of course we'll get an inflated and a biased opinion of the course. So, and we miss out all the valuable feedback from the non-completers whose response are in some ways even more important for us to improve the course. So how we do this? So in fact, we ask the learners if they're satisfied with the course twice, once after first week and once after course end. So we choose first week because that's when learners first complete their assignment. That's our best guess. Probably that's when learners will have a rough idea what this course is all about. So interestingly, we found out learners' opinion do not really change much from week 1 to end of course. But actually week 1 captures more course non-completers than the end of course. And plus, from the business side, week 1 responses also give us a tighter feedback loop, which is good for the product. So that's why you mainly use the week 1 responses as the metrics for tracking internally. So you may encounter different types of selection bias in your own work. So before you start, just try to envision what the potential bias there could be, and then try to come up with ways to cope with it or mitigate it. It could be some tweaks on the UI experience, or it could be the survey design, or it could be even how you frame the questions. Or it could be some ad hoc techniques you get to use to correct the selection bias in the analysis part. So overall, be smart about what kind of users you want to attract and pay attention to the hidden selection bias. The second learning is follow-ups may be needed for actionable feedback. So this is an example of how we do satisfaction survey. So in the beginning, we ask our learners to read the content, and then we provide a free text box so that they can write whatever they have in mind and want to share with us. Soon we discovered this doesn't really give us a lot to go on with. People will write, oh, I love this course, or this instructor sucks. It's pretty one-dimensional and lacking in depth. So later we adapted this into a 2-step process. We ask the learner to read the content as before, and then we lead them to a longer survey where we ask them those targeted and focused questions. So in this way, the response rate is lower than before, but we got much more actionable feedback. So last learning, acknowledge limitations of user voice and pivot as needed. So we try to understand what component in teaching matters the most. For example, is the instructor being warm and personable more important, or is the instructor being able to make the content really structured and engaging more important? So we listed several these important components or aspects, and we asked our learners, how do they feel about these things? Unfortunately, we cannot really infer a clear read from the user responses alone. Of course, teaching is a really difficult concept and question. It's one of the many still open questions we have here at Coursera that we'll continue to work on. So overall, just to recap, here are the tips. Number 1, be aware of the selection bias. Number 2, iterate and extend as needed for actionable feedback. And number 3, acknowledge limitations of user voice and be open to pivots. So besides all those, user voice can also power data products, where Aaron will tell you all about it.
Okay, thanks. Hi, everyone. My name is Iron Kai. I'm a data scientist at Coursera. I'm working on discovery data products. So today I'll be sharing some case studies of building discovery data product. First, let me explain again what we mean by data products and discovery data products. So data products are products that facilitates an end goal by the use of data, and discovery data products are data products that aims at improving users' discovery experience. Discovery data products are generally powerful tools that are extensively used across different industries to bring users back to the site and get them more engaged with the products. Some commonly seen examples of discovery data products are recommendation emails, featured list, and related products, which are all empowered by leveraging users' historical behavior data. Next, I'm going to discuss 2 case studies of building discovery data products, search ranking, and skill tagging. In search, users are looking for a learning product by providing a query. We likely have it, and we want to help them find it very quickly via search ranking. Users expect to see products at the top of search results are more relevant to the search query that they provided. So text similarity is certainly an important factor to be considered in search ranking. However, pure text similarity-based ranking that doesn't incorporate user search behavior does not necessarily reflect users' true interest and preference. We need to consider both factors together to identify the most relevant content that users are searching for. How should we incorporate user search behavior? If we divide search funnel into 3 different stages, each progression from previous stage has reflected users' choice and their interest. From stage 1 to 2, where users click on search result for a given query, and stage 2 to 3, where user converts or enroll in a course, in our case, after checking a course. By analyzing the search funnel in this way, we developed a ranking model that incorporates users' click-through rate and conversion rate for any given query. Intuitively, the higher click-through rate and conversion rate, the more likely a course will be ranked higher for a given query. Here, comparing the pure text similarity-based ranking and user behavior-driven ranking results, we were able to understand that by searching with the query feedback, most of users actually are interested in courses that are about leadership and people's feedback within a business organization rather than other types of feedback. A common practice of building a data product in industries is to build an MVP first, typically due to project timeline constraint. And that's what we did for search ranking. Therefore, there are potentially a lot of possible extensions and nuances we could consider as future direction of improvement. For instance, we could try out different optimization goals other than enrollment. We could also extend the product by personalizing the search ranking at different user level. Such iterations are not uncommon, so it is important to build a data product that can be easily extended and iterated on. Now let me switch gear and talk about skill tagging. In this example, users are looking to learn a particular skill. We likely have it, and we want to help them find the right content quickly. To achieve this goal, we need to understand what skills are being taught in different courses. There are two key steps to build a foundation of skill tagging work. Firstly, we need to determine what are valid skills that should be tagged. We need to build a skill library that covers a large collection of skills and spans across different domains. Secondly, we have to collect sufficient and good quality training data in order to build a high-fidelity skill tagging model. In this project, the main challenges are no longer what kind of regression or machine learning models we should build. Instead, we should be creative about finding the solution that can solve the 2 problems here. The solution we came up with to build skill library is to scrape Wikipedia to obtain all the topics across domains. The advantage of using Wikipedia is that it is very comprehensive and it is logically categorized. Another advantage of using Wikipedia is that we're able to enrich and update our skill library due to the frequent update of Wikipedia. We also did some skill standardization work. For example, eliminating the topics that are invalid skill and grouping synonyms into aliases that are mapped to the same skill. For data collection step, we first try to send instructors and mentors email by asking them to tag the skills for the course they teach or mentor. Then we quickly realized that the amount of data collected from instructors and mentors alone were not enough. In addition, instructors and mentors' perspective might be very different from the perspective of learners. So we decided to leverage users' voice, as Ning has just discussed. We started to collect users' skill tagging data by asking them what skills you have learned from this course when they finished a course. Users' voice has turned out to be the most important sources of truth for building our skill tagging model. There are a lot of different ways to apply the results of skill tagging in discovery. One of the examples is we're able to show users some of the major skills that they will be learning from a course in the preview content to help them better decide if this is the right course for them or not. In addition to the two examples that I just discussed, I'd also like to briefly share the general process of building a data product. What's unique about building a data product compared to building an engineering product is that it involves two extra steps of prototyping and initial model iteration. In most of the times, data scientists start from a project from ideas or a hypothesis that may or may not work. So having the prototyping step would help to validate the ideas and hypotheses at an early stage with low cost. Also note that implementation step involves a lot of interaction and cooperation with engineers. Lastly, I'd like to emphasize again that constant iterations are typically a necessary step of data product building process. To summarize, here are some tips for building a data product. First, be creative and bold about framing the problem and finding the solution to the problem. Sometimes you may have to even try out multiple different approaches that fit into your situation. Second, building data products usually involves frequent interactions and cooperations with engineers, so it's recommended to gain some knowledge of engineering technology, even if it's at high level. Third, make sure to design and build a data product that is easily extensible because there will be a lot of iterations down the path. Now that we have given you a broad overview of some solutions, tools, and some case studies of decision science and data products, Wen, who just recently joined us, will close us out with her perspective on the transition from academia to data science and on preparing yourself in the field.
Okay. Hi, everyone. I'm Wen. Is this working? Okay, cool. In this talk, I will be talking about my experience transitioning from academia to a data scientist role here at Coursera. So a little bit about myself. I graduated from computer science department in Carnegie Mellon University last fall. So I have joined this Coursera as a data scientist for for more than 2 months. Okay, so today I'm going to talk about my experience transitioning from a PhD student to a data scientist role here at Coursera. And in the end, I will also share my tips on preparing for data scientist interviews. Okay, so my transition in a nutshell is quite smooth. Why? Like when I was a PhD student, 80% of my time is like sitting in front of a computer, like working with data. And now, pretty much the same. Oh, wait, maybe with better coffee and food. But actually, there are a lot of difference. So I feel like the difference starts with like when you pick a project. Like when you are a PhD student, the decision is made mostly between you and your professor. So you usually care less about talking with people who are outside your field. And your goal is usually to publish, or like you want to build new models or like have better theories. But here in industry, usually as a data scientist, you talk a lot with engineers, designers, and also product managers. So you will feel like you are a piece of puzzle, and you want to place your work in connections with other work, other effort in your team. And your goal is to make a measurable difference. So to be more concrete, here are the process. So usually in school, the first question we'll ask is, what data do we have? Because it's very difficult to get data, especially user data from companies when you are at school. But here, when you are in the company, you pretty much have all the data you can imagine. The question became where should we start? And after you choose the data in PhD, you will usually think about what topic is the most interesting or publishable. But here in the company, you will think which is the most impactful things to do. And then in terms of what methods you should use, and in academia, we will usually try to build cutting edge methods so that you publish more easily, or you contribute more to the literature. But here in the company, you need to consider the efforts of building things and the engineering cost. So you will use something that's most effective. And in the end, the final product of a PhD project usually is to contribute back to the literature, and hopefully someone else or yourself will improve on it. So it needs to be very perfect, because you guys, you have 5 years, and why not make it perfect, right? But here in companies, you don't have that much time, right? So usually we want to make things that work, and then we'll have multiple chances to improve on it. And so we want to push things out first to improve on it. Okay, so what are some typical data science projects? So as Catherine has already mentioned, many of our projects are decision sciencey kind of projects. So when new features are rolling out, we will be monitoring those key metrics and see whether we are underperforming or outperforming. And another type of projects are data projects, as described by Aaron, where we want to build products that facilitates an end goal with data. Okay, so in terms of the programming language I use, when I was a PhD student, I programmed mostly in Java and JavaScript, and when doing data analysis, I use Stata. And after I came to Coursera, now I mostly use Python and R for doing data visualization and analysis. And I also use a lot of SQL queries to grab data from data warehouse. So how I made the change, basically how I learned these things while I'm at the work. The answer is simple, it's Google. So if you encountered a bug, don't worry, someone has already know the answer on Stack Overflow. You just need to find out. Or you find something that's find a concept that you are not familiar with. Don't worry, Google knows Coursera has it. You watch a video and you quickly understand all of it. And after work, you read a book. This is a great book about data visualization and data analysis. And last but not the least, you have all your data scientist friends here, so they help me a lot they tell me a lot of their experience and their, so don't be afraid to ask for help if you're stuck. Okay, so here comes to the final part where I will talk about how I prepared for the data scientist interviews. So when I first trying to prepare for the data science interviews, I actually Googled what kind of skills are required for data scientists, and I was totally intimidated by this list from LinkedIn. And to be very honest, I still don't have half of these skills. So don't be that intimidated. And what I did next was I kind of tried to ask friends hey, what are your interviews look like? And I quickly realized that different companies have very different data scientist interviews. So here are 2 examples. So you can see that some things are similar. For example, asking about probability and rolling dice. But many things are very different. For example, company X asks you more about SQL queries, which company Y didn't care that much about. And company Y asks you more about programming and machine learning, which didn't appear at all in company X interview. So what I'm trying to say here is that before you go to interview, be sure to ask your friends or just check a Glassdoor. Make sure you know what they are looking for. So how I actually prepare for the data science interview. So I used a website called LeetCode. I don't know how many of you know that, but it's a website for preparing you for whiteboard coding. And I also took a Coursera course, which is Data Science at Scale, which is a great course. I recommend it. So this is trying to give myself like a T-shaped data science skills, where my broad skill sets comes from the course, which quickly give you some the data scientist concepts, while the extensive knowledge come from programming and machine learning, which I built from my PhD years and on the LeetCode exercising. Okay, so here are my final 3 tips for data scientist interviews. The first one is like know those interviews, right? So before you go to the interviews, try to know what they are looking for. And during interviews, try to understand what the interview is trying to ask you about. So if you are asking you about data analysis, don't try to break out some complicated machine learning models. And the second tip is that you want to, so what are my tips? Is to get your hands dirty. Okay, so this means that many of the interview questions is very difficult to answer if you have never worked with data before. So try to get some real data and try to answer some real question with the data so that you can answer those questions that require experience. And the third and final tip is build your business savvy. So how to do that? First, you should use that product that company made so that you you will get familiar with the features and understand the competitors and what the company is good and bad at. And also you can read the tech blog of that company and talk to your friends who are working in that company. Okay, so that ends my talk. And I'll hand it to Emma.
Awesome. So that is a wrap on the lightning talks for this evening. Thank you so much to Catherine, Ning, Airong, and Wen for their insights. I'd love to get everybody back up here for Q&A. And Galila,